Okay, this is Florent, the mathematics user, and we are being asked to find the range. Now we are looking at finding the range under functions. Now the functional notation has been given here, and we have 2x minus 3, and the domain is giving us -2, -1, and 0. So to find the range, it's just a matter of picking each value of the domain and substituting it into the functional notation, because each value here represents x. So for -2, we are going to have, so our f of -2 will give us 2 times -2 minus 3. Then we have -4 minus 3 here, giving us -7. Then for -1, our f of -1 will give us 2 multiplying the -1, which is our x value, minus 3 here, giving us -2 minus 3, and finally -5. Then our last value, our f of 0, will be 2 multiplying 0 minus 3, and we obtain -3 here. So therefore the range becomes -7, -3, and -7, -5, and -3. So that's how we solve for the range. Okay, so we are continuing. Now the next thing we want to look at is to find the value of x when the image is given. So on the board we have our question. It says the image of x of a function f x maps to x plus 5 is 15. We should find x. It is nothing difficult. It is not difficult at all. So here this is what you do. You equate the given function to 15. Here the 15 is the y value. So get it very well. So it means the 15 here is not the value of x. So this is what we do. We equate our function 2x plus 15, 2x plus 5 is being equated to the 15. Then now, by normal linear equations, we group like terms. We have 2x is equal to 15 minus 5, and now x is equal to 15 minus 5 is 10 over 2, giving us 5. So that's how the value of x is found when the image is given. Let's prove it. Let's substitute the value of x into the function. So we have 2 times 5 plus 5. So we have 2 times 5 being 10 plus 5 being 15. So that's the proof. Okay, we have another question. It says that given the function and our function maps to 3x minus 1 over x minus 3, what elements of the domain correspond to 7 over 5? It is still the same as finding the value of x. So because we use x for the domain and we use y for the codomain. So here we just have to equate the given function to this. This is the value of y. So we are going to have 3x minus 1 on x minus 3 being equated to 7 on 5. The next thing to do is to cross multiply. So here our 5 multiplies 3x minus 1, and our 7 multiplies x minus 3. Now we expand. So we have 15x minus 5, 7x minus 21. So by grouping like terms, we can decide to bring all the values of x to this side. We have 15x minus 7x, then minus 21 plus 5. 15x minus 7x is going to give us 8x. Negative 21 plus 5 will give us negative 16. So x is equal to negative 16 on 8. Then our x is negative 2. When we substitute negative 2 over here, we'll get 7 on 5. See. So let's prove it. Negative 2 here will give us negative 6 minus 7. Negative 2 and negative 3 will give us negative 5. When you cancel out, you have 7 on 5. And that is the answer. Okay. So under the same function, we are told that what value of x makes the function undefined. Understand that in mathematics, if we have 2 on 0, we normally say the answer is undefined, which means that for the function to be undefined, the denominator should be approaching 0. So this is what we do. We equate our denominator to 0. So our x minus 3, which is the denominator, is equated to 0. Then our x is equal to positive 3. So this is the value of x, which makes the function undefined. Let's prove it. When we substitute 3 here, 3 minus 3 gives us 0. When we substitute 3 here, 3 times 3 is 9. 9 minus 1 is 8. You have 8 on 0. And 8 on 0 is going to be undefined. So for you to find the value of x, which makes a function undefined, equate it to 0.